Simplify the expression. 3 over x plus 5 plus 9 over x plus 7 all over 2x plus 1 over x squared plus 12x plus 35. So we have here, what we have here is a complex fraction. Our goal is to not have, we have a fraction, but within that fraction we have a fraction in the numerator and a fraction in its denominator. And we do not want to have those fractions that's in this numerator that we see as well as the denominator. So we want to first find the LCD. Well, let's look at the denominator of each. When I say each, look at the numerator. We have x plus 5, we have x plus 7. Okay, so they cannot be, or this cannot be factored. But the denominator, your denominator, you have x squared plus 12x plus 35, and we want to factor that. Listing factors for x squared, factors of 35, and which set of factors that we will use, or the two numbers that when we add them will give us the 12. In the middle, of course it's 12x, but in the middle we have the coefficient of 12. We're going to use 5 and 7. So our factors will be x plus 5 times x plus 7. So what we're going to do is take this x plus 5 and x plus 7, and we're going to multiply it to each term that we see. Our goal is to not have to reduce, or we can say divide out, the x plus 5 that's in the numerator of the first fraction, and then the x plus 7 that's in the numerator of the first fraction. And then we'll be focusing only on what we have here at the top that I'm rolling over, the 3 and 9. So before we get to that, I'm going to rewrite this question, and as we rewrite the question, let's go ahead and leave some space between each term in that numerator. So here's the question. We have 3 over x plus 5, leave some space, plus 9 over x plus 7. And that is all over, we have 2x plus 11 over what we factored this denominator to be, x plus 5 times x plus 7. So we're going to take the LCD that was found, and we're going to multiply, or I won't say found, that we factored, and we're going to multiply to every term we see in the numerator and denominator. So let's go ahead and write this out. X plus 5 times x plus 7, x plus 5 times x plus 7. And we're going to do that for the denominator as well. X plus 5 times x plus 7. Then we're going to take each term in the numerator and what we have in our denominator, we're going to divide out the denominators. Now let's look at it. 3 over x plus 5. We're multiplying this by the LCD. We can put it over 1 if you want to see that. Okay, understand that this is multiplication. But we want that denominator of the original fraction to be able to divide into the LCD. So we're going to divide out the x plus 5s, and notice what you're left with in the numerator. This is what you have in the numerator. We have 3 times x plus 7. Okay, 3 times x plus 7. Let's look at the second fraction. What can we divide out here? We have the x plus 7s that we can divide out, and we have 9 times x plus 5. All over. Look at the denominator. What can we divide out? We can divide out the x plus 5s as well as the x plus 7s, and we're left with 2x plus 11. Okay, so I'm going to rewrite this part over again on another slide so we can get it, so you can see it bigger. So this is what we have. So the numerator, we want to get rid of the parentheses, so we're going to divide, excuse me, not divide, but distribute. We have 3 times x, 3x, then 3 times 7, 21, plus, take the 9 and distribute, 9 times x, 9x, and then 9 times 5. We have 45 over 2x plus 11. Numerator, let's combine our like terms. 3x plus 9x, we have 12x. Then we have 21 plus 45, we have 66 over 2x plus 11. So before we finish this answer, we want to make sure that the numerator and denominator is completely factored. If it's not completely factored, we're going to have to factor. So let's look at the numerator, 12x plus 66. Is there a GCF that can be factored out? If so, let's factor it out. And the GCF is 6. Let's factor that out. And we're left with 2x plus 11 over the denominator. Then what can we divide out here? The 2x plus 11s. And we're left with 6.